Rockets are cool. Watching them shoot across the sky even more so. And it seems like lately we're seeing more rockets get launched than ever before. A lot of these launches take place at Cape Canaveral, Florida. Over the last 70 years, this has been one of the busiest spaceports in the world and the home to some of the most important space missions. But why do rocket launches need special places? Why not just launch them from wherever? And why is Cape Canaveral such an ideal spot? Let's start with that last question first. There are two main reasons why Cape Canaveral is such a great spot for launching rockets. The first reason is all about the ground beneath our feet. You see, the Earth is actually flat. I know this might be news to some of you out there, but hear me out. Sure, the Earth is technically a sphere, or maybe a bit more accurately an oblate spheroid, because it bulges at the equator. But when it comes to getting a rocket off the ground, we can pretty much treat the Earth as if it were flat. The second reason is all about where Cape Canaveral sits on that flat plane. It's located around 3,200 kilometers from the equator, which may sound pretty random, but it's actually really ideal. To explain why, let's start with a little physics. When something is in orbit around the Earth, it's traveling around the planet at the same speed as the planet is spinning on its axis. That means here at the equator, everything is going around at about 1,670 kilometers per hour. That's 462 meters per second. Now, since we're going around in a circle, that speed needs to be matched by a centripetal acceleration towards the center of the circle. If it wasn't for friction and air resistance, this would mean that anything sitting on the equator would be weightless. Technically, we are all still being pulled towards the center of the Earth, but the acceleration from that isn't being canceled out by any other forces. So what does this mean for a rocket launch? Well, imagine our rocket launch pad isn't here at the equator, but instead here at about 3,200 kilometers away. As our rocket lifts off and starts heading upwards, the Earth below it is still spinning. This means the ground beneath it is still moving to the east very fast. And just like before, anything that's falling towards the ground should, in theory, be weightless. In reality, though, there is still some friction with the atmosphere. So we don't actually experience weightlessness during launch, but the effect is close enough that you won't feel anything pulling you down. This effectively gives your rocket an initial speed boost of about 462 meters per second. That is, of course, in addition to the speed you get from the rocket boosters themselves. Now, this is already a big deal. Getting a free speed boost from the ground beneath your feet reduces how much energy you need to put into the rocket, making it easier and cheaper to launch. But it gets better because the further away from the equator you are, the faster the ground beneath your feet is moving. The rocket launch pad at Cape Canaveral, Florida is about 25 degrees latitude, which means the ground beneath it is moving faster than the launch pad at 0 degrees latitude. The speed boost from the ground alone isn't enough to get a rocket into space, but it helps a lot. And that's why rockets are often launched from places like Cape Canaveral. But that still leaves us with another question. Why do rockets need to go into space in the first place? Why can't they just stay on the ground? Well, to answer that, we need to talk about escape velocity. Escape velocity is the minimum speed an object needs to escape the gravitational pull of a planet and never fall back down. We usually calculate this for rockets taking off from the surface of the Earth. And for a rocket to be able to do this, it needs to reach a speed of more than 40,000 kilometers per hour, which is more than 11 kilometers per second. Reaching that speed requires a lot of energy. For comparison, the Saturn V rocket that took humans to the moon for the Apollo missions could generate about 35,000 kilograms of thrust. That was more than twice the weight of the rocket itself. That incredible amount of thrust generated 40 tons of force to move the rocket upwards, overcoming the pull of gravity. But once the rocket clears Earth's atmosphere, there's nothing to slow it down. So as long as it keeps moving forwards, it will never fall back to Earth. Of course, in reality, things aren't quite this simple. If our rocket was taking off from rest, it would require that full 40,000 kilometers per hour of escape velocity to break free of Earth's gravitational pull. But it doesn't start from rest. And because of that, it doesn't need to hit 40,000 kilometers per hour. Instead, it just needs to get anywhere near that speed. To illustrate this point, consider a ball thrown straight upwards. The faster you throw the ball, the higher it goes. If you throw it slowly, it will eventually stop moving and fall back down. Throw it faster and it will go higher, but it will still eventually fall back down. However, if you could throw the ball really, really fast, then it would keep on going forever. It would never fall back down to Earth. In this case, you would have exceeded escape velocity, and the ball would leave Earth's gravitational pull and never return. For a rocket, we don't need to aim for a particular height. Instead, we want to achieve a certain speed. The faster the rocket is going, the higher it is above the surface of the Earth. If it's going slow, then it will drop back to Earth. But if it's going even just a tiny bit faster, it will keep climbing indefinitely. And that's why orbital mechanics work the way they do. You don't need to hit 40,000 kilometers per hour exactly. You just need to get close enough, but how close is close enough? This is called the orbital velocity, and it depends on how high up you want to go. The higher you want to go, the slower you need to be. At the surface of the Earth, you need to be going almost 8 kilometers per second. But 200 kilometers above the surface, you only need to be going about 7.85 kilometers per second. And that's where Cape Canaveral really shines. Because of its location and the speed boost the Earth provides, rockets taking off from here need to get their speed up to less than 8 kilometers per second, which is definitely challenging, but it's a whole lot easier than needing to reach 40,000 kilometers per hour. In fact, that Saturn V rocket that lifted 40 tons off the surface of the Earth would only need to produce about 15 tons of force to do the same thing from Cape Canaveral. That's why so many rockets are launched from places like Cape Canaveral. They're perfectly positioned to take advantage of the rotational force of the Earth. Of course, there are other factors to consider as well, such as the direction the rocket is facing. You always want the ground beneath your feet helping you move forward, not slowing you down. That's why Cape Canaveral faces east. And there's also the issue of the ground beneath your feet moving away from the rocket exhaust. But those are engineering problems that can be solved. There are other spaceports around the world that take advantage of the Earth's rotation, like Plesetsk in Russia and Jiuquan in China, but Cape Canaveral is by far the best. Its location and infrastructure make it the perfect place to launch rockets. I hope you enjoyed this episode with a special thanks to my patrons. If you want to support the channel and have your name added to this list, then you can do so today at a website. Until next time.